recording. Making an equivalent battery using Thevenin method. Acha, by the way, guys, some reduction in the syllabus for CBSE has been done this year, but
Yes,
don't
sir.
worry, NTA
Yes,
has
sir.
not discussed any reduction in the syllabus. So basically, JEE and NEET syllabus is going to be the same. Abhi tak to. There is no update on that. So, anyways, for any given circuit, if we want to find out just give me 2 minutes, guys. 2 minutes. For any given circuit, if you want to find out the potential difference across 2 points, then we use Thevenin's method. Okay. So basically, what do? We try to find out. For example, I'll give you this question. With the help of examples only, we'll able to solve every type of question. So, suppose you have a battery 6 volt, 4 volt, and 3 ohm resistor, 5 ohm resistor, and another 6 ohm resistor. And there is one more battery over here, and like this. And they are asking you find the current across 5 ohm resistor. So what is the first thing which you will be able to see over here? See, this is not symmetric and this is not anything at all, right?
Yes, sir.
So what is the first thing which will come to your mind? How will you solve this question? You will either use nodal or either use Kirchhoff's voltage law,
Sure.
right?
Yes, sir.
But there is another method which is called as Thevenin's also, which will be used somewhere in maximum power transfer theorem and in RC circuits as well. So we'll try to do exactly with the help of this particular thing. See, whenever it is just pure resistive circuit, batteries and pure resistors are there, you can use KVL. It's easier, right? This method will be helpful for solving RC circuits. So see, first step, what you do, where do you need to find the current? You need to find the current across 3 ohm, right? Hello? Yes or no?
Yes, sir.
5 ohm.
So basically you want to find out across 5 ohm, right? So across 5 ohm you'll draw 2 points. Can you see I have drawn this 2 points A and B? So draw 2 points on the circuit according to the question, right? So those 2 points we said it was what? A and B. Now what to do after this? Once you have done marking these points, what will you do? You will just Control C and Control V. Step 2, remove the circuit elements across A and B. So basically what will you do? You will remove this 5 ohm resistor. Can you see? Please pay attention to these steps. These steps are very important. So whichever current or whichever terminals you want, you will just do what? You'll remove it from the circuit. And can you see I removed this 5 ohm resistance from here? Is the first step clear?
Yes, sir.
Remove the circuit across A and B, or you can say make the circuit open about AB by removing the 5 ohm resistor. I'm trying to do it with the help of a question so that it will be easier for you to understand. The first step is basically we removed this resistor AB. So now tell me this particular thing, guys. If the circuit is removed from AB, will any current go through AB? Through this branch? Can you see any current? Can it go through the 4-volt battery and through AB? Can it go?
No, sir.
No. But can you see there is one more part of the circuit where the current can flow?
Yes, sir.
So just flow the current in that direction only. The step 3 is to if any closed circuit is produced, closed circuit or part of circuit is present, flow current in it. Kabhi, if there is any part which is having certain closed loop is formed, then you need to flow the current in it. So basically step 3 is basically a current of, let's say, I will flow from here to here to here to here. Can it go through this AB branch? No, right? So the same current, can you see a current I is flowing in this loop? Yes or no?
Yes.
Yes.
You will calculate this current. What is this current equals to? Can you see this 6 volt and 4 volt, they are supporting each other? Can you see the current is coming out from the positive terminal, entering from the negative terminal and coming out from the positive? So both the batteries are supporting each other. So I'll write 6 plus 4 divided by, can you see this 6 ohm and 3 ohm will be in series? Can you see 6 ohm and 3 ohm in series? So 6 plus 3 is how much? So 10 by 9 ampere. Is this clear? Is this clear?
Yes, sir.
Okay. Now step 4. Find the net resistance across AB by replacing all the batteries. By replacing all the batteries with a connecting wire. Okay, so basically what will you do once you have flown the current and all, you'll just go back to the initial circuit. Can you see this circuit? Control C. You'll go back to the initial circuit, not from the step 3. So basically step 4, what will you do? This thing, and there was no 5 ohm resistor as well. So 5 ohm resistor is not there. 4-volt battery is not there. So can you see, guys, I removed all the batteries. I removed all the batteries and just replaced all the batteries with a connecting wire. So can you see? The circuit became somewhat like this. So can you see across AB, can you see 6 ohm and 3 ohm are in parallel? Across AB, 3 ohm and 6 ohm are in parallel, yes or no?
Yes, sir.
Now you could understand properly, right? So wherever there were batteries, I replaced those batteries. And can you see it just a wire, wire, a wire, a wire. So somewhat like this will be formed. Yes or no? So you will calculate this resistance RAB, which is basically 6 ohm and 3 ohm in parallel. So 6 plus 3 is how much? What is the, how much is this?
2.
So 2 ohm.
So,
है ना? Now what to do after this? Or do one thing, do one thing. This is one is basically. Did you start writing or this thing? कि नहीं? चलो जान दो. We'll do that. I wanted to replace this step 4 by step 3. Did you write already?
Yes, sir.
Okay, chalo, no problem.
yes, sir.
Okay. So step 5 is to go back on step 3 and find the open circuit Kirchhoff equation across. So basically what will you do? So you'll find out the open circuit Kirchhoff across. This was 4 volt, this was 6 volt, right? So you'll find the open circuit Kirchhoff across AB. Can you start from here, guys? I'm writing all these steps. You don't need to copy all these steps. Abhi copy kar lo. But once we'll start with the questions and all, you'll understand. It's not that difficult. It's a 3-line question and just finish. Although you need to draw it again and again. So can you see if I start open circuit Kirchhoff? So can anyone apply open circuit Kirchhoff for me? VA. Then you are entering from the negative terminal of the battery. So plus or minus? Guys, plus or minus?
Plus.
So
Yes.
plus 4. Can you see when you go through this 3 ohm resistor, are you moving in the direction or in the opposite direction?
Opposite direction.
Opposite.
So opposite direction. So plus 3 multiplied by I. Where what is I? I was how
10
much?
by 9.
I was 10 by 9. You calculated it earlier, right?
Yes, sir.
So into 10 by 9. उसके बाद में plus this 10. फिर उसके बाद did you reach VB? Yes or no? So is equals to
VB.
So can you see from here VA plus 4 into 3 into 10 by 9. So this is 10 by 3. 4 plus 10 by 3 is 22 by 3, right? Yes or no?
Yes, sir. Yes,
Is
sir.
equals to VB. So can you see over here? You need this thing to be positive. So you'll write VB minus VA is equals to 22 by 3. It doesn't matter whether which is greater, B is greater or A is greater. You need to write it like this so that this thing, whichever VB minus VA or VA minus VB comes, it should be positive. Okay? By doing that, you will get an idea ki which is bigger. So from this equation, potential at B is greater than potential at A. Yes or no? Yes or
Yes,
no,
sir.
guys? So from here, you will get an idea
Yes,
about
sir.
which is bigger. So B is bigger, A is smaller, right?
Yes, sir.
So basically,
Yes, sir.
what will you do, guys? What will you do if this circuit is given to you? Last step is no, no. So note this VB minus VA, this potential difference across A and B will act as the EMF of the equivalent battery. So basically what will you do? You will replace just the whole circuit. Which step is this? Step 5 or step 6? Replace the whole circuit with just a battery. A single battery. And single internal resistor. So what are the important steps over here to calculate this open circuit Kirchhoff and this RAB thing? These are important, hai na? So what will you do? You will just say this whole circuit, Control C. Will just become. Can you see? Just take internal resistance, and I'm connecting a battery like this. Why am I connecting the positive terminal towards B? Why did I connect a positive terminal towards B?
B is at higher potential.
Because B was at higher potential. So basically this VB minus VA will be given your E equivalent. So basically what will you do? You'll just connect this across a 22 by 3 volt battery. And what was the internal resistance of this thing? E equivalent is 22 by 3 volt. And what was the internal resistance across AB? 2 ohm. Right? So basically this circuit becomes like this. Can you see? It's just one battery and one. It's a optional method if you want. If you don't want that, then no need है ना, ऐसा कोई जरूरी नहीं है. Now step 7 is to put back the elements of the circuit. In this question, it is here the 5 ohm resistor across AB again. And then solve. So basically what will you do? Across this thing, you just put back why am I not able to move it? I think my screen froze, guys. भाई इसको सबसे पहले बाहर भगा दे. So guys, what will you do after this? You'll just connect this 5 ohm resistance back. And can you see then after this you need to solve. 5 ohm, 2 ohm is how much? 5 ohm, 2 ohm. What is the net resistance? 7 ohm. And E equivalent is 22 by 3 volt. So basically what will be the current? Current will be 22 by 3 divided by 7, and that will be 22 by 21 ampere. Answer. Is this clear, guys? So a little bit steps is needed. I'll revise it for you. Whenever you are done writing, then tell me. Shall I scroll up or down, guys? Guys, shall I scroll up or down?
Let it be here.
Huh? Let it be here. Okay. Did you understand the method? The method is easy once you start applying it. Don't think of the steps too much. Start solving it automatically. This will come. Like I'll give you one question, then understand it easily. Today I'll be done with current electricity, guys. Complete current electricity is done, and then from tomorrow onwards we'll be starting with MEC. We'll be completing MEC within very few time, because you already have basic knowledge about electrostatics and all. The normal integration differentiation I can leave it to you, right?
भैया चलो बहुत दूर है हम लोग गाड़ी लेनी पड़ेगी दोनों ही टूट गए हमारे करना है क्या
How will this thevenin be applied in normal RC circuits and all? We'll see.
और गया और मैं ले लिया मैंने भाई गाड़ी कहाँ से लेनी गाड़ी से नहीं आ जाओ वो ही 15 रुपए फीस भर जाएगा
Guys, are you done writing?
ट्रांसपोर्टेशन को मालूम
Yes, sir.
Okay. Yes, guys, please unmute your phone. Please unmute everyone. This is the last time I'm telling you. मतलब 2 मिनट होता नहीं और सब म्यूट कर देते हैं वापस से. Please keep your phone and unmute. I should hear people saying yes or no at least. तो शांत नहीं बैठना है यहाँ. Anyways, I'm giving you another question. Please unmute, guys, है ना. मेरे को अब next time से जो दिखेगा I'll send them to lobby. है ना? I'll just kick them out. There is an option, right? Let me check. Put in waiting room. Yes, there is an option. I'll put you in waiting room. Okay. So whenever you will message me after coming in the waiting room, then I will take you back. So it's better to not go out. Anyways, this is a simple question on grouping of batteries. If you remember, ये question याद है? ऐसा कुछ you already did. There are two batteries. This is 12 volt 3 ohm, and this is 18 volt 6 ohm, and I have connected a 4 ohm resistor over here. Now the question is, find the current across XY. Okay. Oh, sorry, XY can. Oh, no. Find the current across 4 ohm. This was the question. Okay. So how will you do it, guys? First thing first, you'll draw the whole circuit and remove this 4 ohm from here. So if I draw the whole circuit again, will it look like this 12 volt battery is there? This 3 ohm resistor is there. This 18 volt battery is there, and there is this 6 ohm resistor over here. Yes or no? 18 volt. And wherever this 4 ohm was, I just assumed these 2 points are X and Y, and I broke the circuit across XY. So can you see I removed the 4 ohm resistor? This is your step 1. Yes or no, guys?
Yes,
I'll
sir.
draw another
Yes, sir.
circuit. You'll do it like this. I'll draw another circuit over here without the batteries and all. So can you see if I draw without the batteries, will it just look like a 3 ohm resistor and a 6 ohm resistor over here across XY? Yes or no? So you need to draw
Yes,
these
sir.
two figures. First this figure and second this figure. This figure will help you to calculate what is the resistance across X and Y. So 3 ohm, 6 ohm, parallel again.
Yeah.
So this will be 2 ohm. So this is your whatever step it is. Here you will find out, can you see when you broke it across XY, is there any current flowing in this thing? So can you see
No.
a current can go
No,
from
sir.
here, upper circuit, can you see upper part? A current can go in this direction, right? In this loop. Told you if
Yeah,
there is
upper
any loop
direction.
present in this thing, the current can go in that. So let's say current how much goes? Can you see 18 volt and 12 volt are supporting each other in this current? So the current
Yes, sir.
will be, or if you don't want to, sir, whether it is supporting or opposing, you can directly use KVL. So let's say current I is flowing in the loop. So let's start from here. Plus 18 minus 6 into I plus minus 3 into I, and then plus 12 is equals to 0. Yes or no? So from here, can you see I is basically 18 plus 12 upon 6 plus 3. Can you see both were supporting each other? So hence that is that. Are you getting my point, guys? So current will be how much? 18 plus 12 is 30, and 6 plus 3 is
10 by
10
3.
by 3.
so this will be 10 by 3 ampere. Once you find out the current, then you will find out what is the potential difference across X and Y, right? So Vx
Yes, sir.
minus 18 minus I into 6. So minus 10 by 3 into 6 is equals to Vy. So can you see from here Vx will be how much? Vx minus Vy. This thing will go to the left hand side and will become positive, right? So 10 into 2
Isn't
is
it plus
20 and
18?
20, 38, right? Yes or no, guys?
Yes, sir.
So basically this thing became 38. So now, एक second. 18 volt was here, 6 ohm.
So it should be plus 18.
Plus 18.
Yes, sir.
Nice. So this will be 20 plus 18, so this will be 2 volt. Yes or no? Let's see over here. It was going from the negative terminal of the battery, hence plus 18. I made a mistake. So basically Vx minus Vy you are getting is how much? Toward this thing came positive, so this will behave here, they are E equivalent. Okay. So what will you do? The final circuit from here, you will just assume that there is one battery and X was bigger, right? X was bigger, right?
Yes.
So basically,
Vx minus
Yes,
Vy.
sir.
so can you see E equivalent, which is 2 volt, connected with RXY, which is 2 ohm, and this thing is connected to X and Y. And now after this, the final step will be to, guys, last step will be to write this 4 ohm resistor, and what is the current now? 2 divided by 2 plus 4, which is answer. Is this clear?
Yes, sir.
So basically this method is
Yes,
your
sir.
Thevenin. Did you understand? In steps it looks like very big, but can you see, you just need to draw 3 diagrams and it will be over. Can you see, only 3 steps we did? Calculation of this, if any. This step is optional, if any. If there is any loop present apart from the branch which you broke, then flow current in it. And then this one. Any doubt? Please remember, guys, this method is optional. You don't need to mug it up. Is it fine? Is it fine, guys?
Yes, sir.
Yes, sir.
Shall I give you one more question? Will you be able to do it using Thevenin's method? एक बार last try कर लो, and then we'll move to the we'll move to the maximum power transfer theorem. Again, I told you that there is one part which you generally do using Thevenin. It is easier. X, Y, 4 ohm, 8 ohm, 20 volt, and then last one is 10 volt. So guys, again the question is find the current in 4 ohm resistor. So again, what will you do? How will you do it, guys? 3 diagrams, na?
Yes, sir.
Yes, sir.
Shall I draw them? Will you be able to draw it?
Yeah, yes, sir.
The first diagram which we'll draw is basically without the 4 ohm resistor. Yes, guys. The second diagram which we will draw is without all the batteries. Mhm. Can you see the second diagram? Any doubt? Guys, can you see the second diagram is without any batteries? The 8 ohm resistor is still there, 8 ohm resistor is still there, 6 ohm resistor is still there. Okay. So now what is the resistance across X and Y? Can you see
Yes,
this
sir.
8 ohm
Yes,
and
sir.
this 8 ohm are in parallel with each other, and this 6 ohm is in series with that, right? Yes or no? Are yes or no?
Yes, sir.
So these are in parallel with each other, and the combination is in series
Yes,
with
sir.
6 ohm. So basically, I'll write RXY is basically 4 8 into 8 upon 8 plus 8, which is 4 plus 6. So can you see the net resistance across? Hello? Is my voice breaking now?
No, sir. Now it's fine.
So can you see these two are in series or in parallel with each other, and the combination is in series with 6 ohm. So we rotate like this. Any doubt in here? Yes or no? Guys, did you
No,
understand
sir.
the method? Any doubt in this? अब मेरे को एक बात बताओ. When you
No,
break the
sir.
circuit between X and Y, will any current flow in this branch? Will any current flow in this branch? No, right?
No, sir.
But
No,
is
sir.
there any loop present
sir.
where the current can flow?
Yes, sir.
So
Yes, sir.
let's flow a current, and 20-volt battery will rule. So high current. Now can you see in this example, this 10-volt battery is opposing the 20-volt current from 20-volt battery? Yes or no? So I can write 20 minus 10 divided by 8 plus 8. Or you can, if not, you can use directly Kirchhoff. So it will be, let's start from this point. Uh, minus of 8 into I minus 10 plus 20 minus 8 into I is equals to 0. So can you see from here, when you solve this, this is 20 minus 10 and this is 69. Yes or no?
Yes, sir.
20 minus 10 divided by 8 plus 8 is basically I. So it's up to you, whichever concept you want to use. So 10 divided by 16, which is 5 by 8. So once you found out the current, you will apply the open circuit Kirchhoff across XY. So Vx minus 8 into I. Oh, sorry, plus 8 into I. Why plus? Because we are going in the opposite direction. Yes or no?
Yes, sir.
Minus 20. Then can you see, was there any current flowing through 6 ohm resistor? Was
No.
there any current flowing in the 6 ohm resistor? So plus 6
No,
into
sir.
0 or minus 6 into 0, doesn't matter. Then there is this battery. You are entering from the positive terminal. So minus 10 is equals to Vy. Is this clear, guys? This is open circuit Kirchhoff, yes or no?
Yes, sir.
So when you solve it, what will you get? What is yes, guys, please tell me. No, 8 say 8 will get cancelled. This is 0. This is 25. So minus 25 minus 10. Guys, no, sorry. Minus 30 plus 5. What is
15,
minus
right?
30 plus 5?
20.
minus 25 equals to Vy, and from here Vx minus Vy is equals to 25. This will act as your equivalent. Is this clear? So after this you will do what? You will just make a single circuit. Which was bigger? X was bigger or Y was bigger?
X.
So X was bigger, so you will connect this X across the bigger terminal. And what should be this thing? 25 volt. And what is the internal resistance?
10 ohm.
10 ohm. So can you see, guys? This whole circuit is being reduced to this. And later on, after this, what will you do? You will just put back the, which resistor did you remove? You removed the 4 ohm resistor.
4 ohm.
So 4 ohm resistor, and what is the final current? It is basically 25 divided by 10 plus 4, which is 25 by 14 ampere. Answer. Is this clear, guys?
Yes, sir.
Please look at it once, and then tell me if you have any doubt. Can you see only step 1, step 2, and step 3? 3 steps: RXY, the current if any, and step 3. Step 1, step 2, step 3, or it's up to you, whichever you want to follow. It's not necessary you need to follow exactly those steps. The methodology is important. Is this clear, guys?
Yes, sir.
Chalo, with this thing, there is one more thing which is called as branch removal technique, but wo not necessary because I think you people have perfected nodal, right? Nodal Kirchhoff you have perfected. I assume this because we have given enough time on this current electricity. Yes, guys.
Yes.
Yes, sir.
Let's discuss some questions on thermal, the maximum power transfer theorem, which will involve the Thevenin. Are you done, guys?
Yes.
Next question. Does anyone remember the maximum power transfer theorem? When is maximum power transferred from a battery to a external resistor?
External resistance is 0.
When external resistance is equal to internal resistance of the battery.
Yeah.
That was maximum power transfer theorem. When is the maximum power transferred to an external resistor? Is basically when the internal resistance of the battery and the external resistance are equal. So 6 ohm, 4 ohm, and in spite of giving you this, we can start with this. 5 ohm, 6 ohm, 4 ohm, 20 volt, 10 volt, another 10 volt, and this resistance R, which is variable. Okay. Now the question is, find the value of R. You don't know the value of this. So find the value of R for which maximum power is transferred to it. So what do we want? We want to transfer maximum power to this R, right? But now there are many batteries over here. So we don't know which battery will supply what, right? Yes or no, guys?
Yes, sir.
So see, in this particular type of questions, you just need to follow only a single step of Thevenin. What is that single step of Thevenin? First thing first, you will be not calculating anything or like that. This will be 6 ohm, this will be 5 ohm, this will be 10 volt, you'll remove this R because you want to find out the maximum power across it, right? So you'll remove this R between point X and Y. So let's name it X and Y. There is this 4 ohm battery, 4 ohm resistor over here, 6 ohm resistor over here, and 10 volt. Yes, guys, was this the circuit? What was the battery above? 20 volt. And this is 20 volt. So first step is basically you remove this XY. Yes or no? The second circuit which I'll draw is basically removing all the guys. I'll remove all the batteries. Yes or no?
Batteries.
So all the batteries
Yes,
have been removed.
sir.
Can you see this XY? This is your 5 ohm, this is your 6 ohm, this is your 4 ohm. Yes, can anyone tell me what is the resistance across XY? 4 and 6 are in parallel. Yes?
Yes, sir.
4 and 6 are in parallel. So 4 into 6 upon 4 plus 6, which is basically 24, 24 upon 10, 2.4. 2.4 plus this 5, which will be equals to 7.4 ohm. Yes?
Yes, sir.
Yes, sir.
But that's it. Now after this, what you do? You basically calculate I and E, right? You don't need to do that because we just found out what is the internal resistance across XY. After solving this thing, you get some value of E equivalent, right? So ultimately, the final thing which you do is basically X, Y. You connect it across E equivalent. Doesn't matter whether X is bigger or R is bigger, and you connect it across XY, right? Yes or no, guys? So can you
Yes,
see
sir.
over here, when you will connect back the resistance capital R, this and this should be equal. Then only the maximum transferred, maximum power will be transferred, right?
Yeah.
So the
Yes, sir.
maximum power will be transferred to R, whatever. Don't care, don't need to calculate also. Maximum power will be transferred to R. So can you see only one step of Thevenin solved this problem? Transferred to R when R is equals to the internal resistance across XY, and which is basically 7.4. And that's the answer to this question. Any doubt, guys? I told you, that there is one concept of maximum power transfer which requires Thevenin as well. I told you, this thing.
Yes,
So
sir.
whenever we'll
Yeah.
do Thevenin, I'll teach you. One more question we'll do. Today we'll be done with current electricity for good, and we spent an awfully lot of time on that. So I hope current electricity is pretty much clear to everyone. And whenever I'll give a test on current electricity, I expect every student to score above 90 in that. Okay, guys?
Yes, sir.
Yes,
Abhi
sir.
only
Yes,
few
sir.
students have scored above 90, and 90 above score is good. The paper which I am setting is on on JEE mains easy level, so it will cover NEET as well as JEE mains easy wala. Once once you're will gain a little bit confidence in solving and all. So I'll set a paper in which it will be like it will be medium level questions, and then hard level, advanced also. Hard level will be going in advance. So we'll take these papers again when we'll be starting with the revision point of view after completion of syllabus and all. So anyways, sure, a question. Homework. Can I give a homework?
Yes, sir.
This is 10 volt. This is 20 ohm. This is 6 ohm. This is Acha guys, if they said ki what is the maximum current which flows through R, then that implies then you need to calculate this E equivalent as well. Okay? If they say to find out the current, then you need this E equivalent, right? And one more step will be added. I will be equals to what? E equivalent divided by Rxy plus R. Yes or no, guys? And please remember these two will be equal. So hence, accordingly, you can solve if someone asks you that. So, anyways, the question is this. This battery, and where is the last one? I'm modifying the question a little bit, okay? This is a variable resistance whose value can be changed. 20 ohm, 4 ohm, 6 ohm, 10 volt, 20 volt. Now the question is, find the value of R for which the current through 6 ohm is maximum. Please remember, guys, where am I doing maximum? I was doing across 6 x y. So please remember, you'll in this case you will not choose the points across x and y. You will choose it across 6 ohm. Okay? Is this clear, guys? Will you be able to find the value of R for this?
Yes, sir.
Chal. Now after this, let's come back.
What will be the answer?
What?
What will be the answer?
Answer I don't know. I framed this question in the question which I had. It was the similar to this one. It was similar to this one. Find the value of R for which the current or for which the power transfer to it will be maximum. I don't want that, so I changed the question a little bit. I want what is the value of R for which the current through or for which the power transfer to the 6 ohm is maximum. So I changed it a little bit. So I don't know the answer. If you want, we can leave some space so that we can solve in the next class. Okay? Once you're done with writing the question, just tell me. Let's come back to RC circuit. So with this thing, current electricity is complete. RC circuit with some more questions and that's it. All these are nodal based questions.
Okay.
Yes, guys, please do this question now. These questions are based on RC circuit and all. Okay? Now there will be a resistor and there will be a capacitor. Question. There is this 2-volt battery, R resistance, one more R over here, one more R over here, and then one more R over here, and one capacitor C. And there is this switch which will be closed at t equals to 0, and there is this V volt battery. So guys, can you see the circuit like this? You don't know what is the value of R. Now the question is, find the time constant for the circuit in the figure for charging of capacitor. So sir, this question looks very new, sir. Yes or no? How will we solve this thing, guys? Acha. Everyone remembers this, right? Whenever there is a RC circuit which is connected to a battery, then everyone knows what is the time constant of this particular thing. What is the time constant in this case? What is the time constant in this case, guys? Hello? Guys, do you remember time constant? Everyone? Lecture 16, right?
P by RC.
P by RC. nahi. P was equals to R into C. Can you see? This was the time constant.
Yeah.
I told you. T equal to RC. Can you see? T equals to RC is basically called as the time constant, right? For RC series circuit. Yes or no? Everyone remembers this, right? So now
Yes,
see
sir.
over here.
Yes, sir.
We know that whenever this type of circuit is there, then the time constant is RC. Yes or no? So if someone tells you to find out what is the time constant for this type of circuit, so is there any method by which you can convert this to this sort of thing? Is there any method by which you can convert this to this? Yes or no? है या नहीं है? So when
Yes,
I
sir.
want to convert this to this, I need to use something called as Thevenin's method. Are you getting the point? So basically, what will I do first? What will I do first? First thing first, I'll just see. Can you see over here? There are lots of resistors over here. If the switch is closed at t equals to 0, so I need to find out what is RC, right? R into C. So can you see over here? R and R. Oh, sorry. This whole thing will become something like this. 2V R V, the switch which was closed, right? Then capacitors, you'll remove it across the capacitor. Can you see there is only one capacitor and many resistors? So remove this capacitor from here. Oh, this resistor was also R. So one more R and one more R. Yes? Yes, guys? Hello?
Yes,
Yes,
sir.
sir.
So this is your X and Y. This is your X and Y. Now what to do? Just simply apply Thevenin's. Exactly, just we applied Thevenin. We just remove the capacitor from here. So when we remove the capacitor from here, you can apply Thevenin over here, right? Guys, are you able to apply Thevenin over here? What will be the value of current? Will there be any current flowing in the circuit? Yes, current will flow only in this part. Yes or no?
Yes, sir.
So
Yes,
the
sir.
current will only
Sir.
flow over here. So let's say current is I. So I will be equals to 2 divided by. Can you see R and R? So 2V divided by 3R. Will this be the current? Yes or no? Will this be the current?
Yes, sir.
And can you find out open circuit Kirchhoff across X and Y? So Vx minus V plus I into R plus 0 into R is equals to Vy. Why do I write this 0 into R? So that you will understand this particular thing. Whenever no current is there, so I wrote it 0. Yes? So can you see
Yes,
from
sir.
here R and R will get cancelled over here, minus V plus 2V by 3. So minus v plus 2v by 3 is v by 3, right? So vx minus v by 3 is equals to vy, and from here vx minus vy is equals to v by 3. Yes? Yes, guys?
Yes, sir.
So basically v by 3 you got. Also, what will you do after doing this circuit? Then you'll just draw it again without all the batteries. So r r one more r, then y, and this will be your x, right? So can you see over here, this r and this r is in series, and that is in parallel with this 2r. Yes or no, guys?
Yes, sir.
Yes,
This
sir.
r and this r is in series, which is in parallel
Yeah.
with this r, and whatever the combination is coming, which will be in series with this. Are you able to see it?
Yes, sir.
So 2r
Yes,
and
sir.
r, it will be 2r by 3, and this 2r by 3 and this r is in series. So this will be the net resistance across xy, which will be equals to 5r by 3. Okay, so basically that circuit which you have, will it be converted to like this, an equivalent battery of v by 3? Yes or no? Yes or no, guys?
Yes, sir.
Yes, sir.
X and y was over here. Sorry. And a resistor of how much?
5 by 3.
5r by 3, and then you will connect the capacitor again. So can you see over here, guys, what is the time constant? Is this thing, can you see it is the same thing as this? All of them are in series, right?
Yes, sir.
So basically this is an RC circuit with a time constant equals to R net across XY. So basically RXY into, which is basically 5R by 3. This is the time constant, and that's the answer. Okay. Acha. Second part of the question is also find the charge on the capacitor as a function of time. So we know this particular thing in the case of RC circuit, Q is equals to Q naught into 1 minus e to the power minus t by RC, right? Yes or no, guys? We know this
Yes, sir.
formula, I
Yes, sir.
guess. So can you see from here, Q will be equals, what will be the maximum charge? Maximum charge, if you remember, it is C into E, right? So C
Yes,
into
sir.
E, can you see C into E? This the maximum charge, CV by 3 into 1 minus e to the power minus t upon RC. What will be RC equals to? 5R by 3. So this will be the function, and this is one of the questions which has been asked in advanced, not even mains. So can you see, guys, how to deal with RC circuits is easier if you know the tools, right? For different things, they have different tools. Any doubt in this, guys?
No, sir.
Shall I give?
Out in the
Yeah. Please tell me.
finding the
Please tell me.
voltage.
Huh?
So why did we take it as 0 there?
Where?
Mm,
Here.
so
Here.
yes, sir.
Because
Yes, sir.
in this resistor there was no current flow, and we were moving from X to Y.
Yeah. So this current which is flowing through this 2 will also not flow through it.
The current which is flowing through this 2 volt will not flow through this R. No, there is no current in this branch because this is open, right? Current cannot flow in a branch which is broken. The loop has to be closed, right? So that's why.
Wow. But in the previous cases, did we consider in that way?
No, we didn't. in here also, can you see?
Yes. Yeah.
Here also it is, can you see no current was flowing to 6 into 0? Are you getting my point?
Oh, okay. Okay.
We were moving from X to Y, no? So X through
Okay.
this 8 ohm, 20 volt, 6 ohm, 10 volt, and Y. So please remember
Okay,
this
sir.
open circuit Kirchhoff, na?
Okay, sir.
Okay. So I guess, guys, this method is pretty much clear to you. Hernan, shall I give you 1 or 2 questions, or shall I start with MEC? Let's give you 1 or 2 questions more. Exactly same question like this. Guys, I'm giving you one more exact question which is based on the previous method. So that's why that will be your homework. Only the circuit will change, nothing else will change. 18 volt battery. Switch. 1 ohm. 3 ohm. 3 ohm. 4 microfarad. 3 ohm. At t equals to 0, this switch has been closed. Capacitor is initially uncharged. Now the question is, find the charge on the capacitor as a function of time. Acha, I could have asked you current also, na? Guys, if I would have asked you what is the current through this 1 ohm resistor, then would you have done like this? Na? You wouldn't have done like this, you would have done something else. So anyways, this is your homework. So I guess these type of questions are pretty much clear to you. This is over, this is over. That's it. Okay? I can give you one more question like this. Suppose. 12 volt, 2 microfarad, 3 microfarad, 4 microfarad, and 1 resistor. Now they are asking what is the current through this resistor. How will you do it? Guys, how will you do it?
Did you take out the resistor like X and Y and then
And
X and Y,
remove
then
this
method.
and then flow the charge. Flow the charge across this. So try this question. Try this question, okay? This is again same thing based on Thevenin only. I'll give one more battery.
so we should find the current through the
You need to find out the current through the battery, current as a function of time across this R. Okay. So basically you need to convert this to what? Just like you did convert it to RXY, will you be able to convert to CXY as well? Yes or no? You connected like RXY, no? In all the Thevenins you did what? You find out what is the net resistance across XY. In this case, what will you do? You will find out what is the net capacitance across X and Y. Is this clear? And then open circuit Kirchhoff, but please remember Q is equals to C into V. So thoda bahut tricky hai. You need to use the concept of Kirchhoff as well as Thevenin together. So karana, try karna. There is always a catch. Anyways, so with this thing, I'm officially done with your current electricity. Any doubts in this? What is the time now?
Could you explain this question once again, the method?
This question again. first thing first, you'll do what? You'll draw the whole thing as it is. And you'll not draw this resistance. Okay? Yes or no, guys?
Yes, sir.
So once you are done with that, what will you do now? Can you see any part of the loop where charge can flow? So charge can flow in which loop? It can flow in this loop.
अपना फोन कॉल करता हूँ डायरेक्ट कॉल करो
क्या
डायरेक्ट कॉल करो
किसको करना?
नंबर बताओ
हाँ, इंडिया वाले नंबर से करना. हाँ
जियो ना
हाँ जी.
बाबू और जियो पे कॉल करो
Okay. Yes or no, guys?
Yes, sir.
What will be the charge which will be flowing to the circuit? Charge will be, can you see this 3 ohm and 2 ohm are in series with each other, right?
Yes, sir.
If this 3 ohm and 2 ohm are in 3 microfarad and 2 microfarad are in series with each other, then what is the net will be equals to 3
6 by
into
4.
2 divided by 3 plus 2, 6 by 5. है ना? Yes,
Yes,
or no?
sir.
Will this be the C net across these two? So it will be 6 by 5 multiplied by 12. So this will be how much? 12 6 is 72, right? 72 by 5 micro coulomb. This is the charge which is flowing. Now, can anyone apply what is across xy? Vx minus Vy. So Vx, can you see no charge was there in this thing? So Vx minus 0 into 4 over here. 0 into 4. Now, when you are going from here,
Yes, sir.
please remember, due to this charge, can you see due to this charge, will this plate be positively charged? And will this plate be negatively charged?
Yes, sir.
Yes or no? So we are entering from the positive terminal of the battery, of the capacitor. So plus or minus? Minus 2 multiplied by, what is the charge?
72 by 5.
Q.
72 by 5.
एक second. So minus Q divided by C. Yes or no? Will this be a potential? Minus Q divided by C. And then you have this 4 volt battery when you are entering from plus. So plus 4 is equals to Vy. I think you can solve this thing to find out what is Vx and Vy. And then you will draw this circuit without any batteries. So once you will draw it without any batteries, it looks like this. 3 microfarad, 4 microfarad and 2 microfarad, nothing over here, nothing over here, and this xy. So can you see now, guys? 3 microfarad and 2 microfarad are in parallel across these 2 points, and it in series with 5 microfarad. Hello, guys. Hello, guys. Hello. My net connection got weak, so I got disconnected from the meeting.
Yes, sir. I can hear you now.
No, I got disconnected
Yes,
from the meeting.
sir.
Net connection is giving some problem. So anyways, 3 plus 2 will be 5, and this 5 and 4 will be in parallel with each other or in series with each other. So 5 into 4 divided by 5 plus 4, which is basically 20 divided by 9 micro. So now you got the CXY. So basically the whole circuit, this circuit can be assumed as the final circuit will be whatever E equivalent comes, you will write it over here, and whatever this C net was there, C net was equals to 20 by 9 microfarad, and this R which you will connect it again. So can you see it will become similar to that? So are you Understanding this particular point, guys? No, it's the same Thevenin method only, but only the values will, or the equation which we write will change a little bit, but still the method is same, right? Yes or no, guys? And what was the resistor, guys? How much was the resistor?
It was R itself.
It was R itself. Okay, so let's give some value. 3 ohm. Connect this 3 ohm again back. So what will be the time constant? How will you calculate time constant? Multiply these two. Answer. Yes or no? So I think this is pretty much clear now, Thevenin. In one lecture, I guess I have cleared it all the aspects of Thevenin, and this will help you. And please remember, this is optional. It's not necessary you need to use this, but in RC circuit, it becomes easier. Otherwise, current will take your life, literally. Current, if you try to do RC circuit using KVL, lots of integration differentiation you need to do. Are you getting my point, guys?
Yes, sir.
Okay, so this is it about current, electricity. Time kitna ho raha hai?
Sir, in the question you asked to find R as a function of time. So
Find the
how do you
current
do
through.
that? This
Okay,
is tau is equal to RC.
I is equals to I naught into minus T by RC. Is this the formula? If you remember, E equivalent divided by R, whatever E equivalent is there, you will find out the value, right? This will be 0. This will be 72 by 10, 7.2. So minus 7.2 plus 4, so 3.2. Hello? Guys, are you able to hear me?
Yes, sir.
Okay. So
Yes,
Vx
sir.
minus Vy will be equals to 3.2 volt. Can you see if I make any calculation mistake, tell me, na? So this is equals to 3.2 volt. And we know I equivalent is basically this. So this will become 3.2 divided by 3. And this will be e to the power minus of t by 20 by 9 microfarad multiplied by. So please remember, this will come. Please don't forget to write this micro. This will make a difference. Okay. So this will be 1 and this will be 3. So this will be 3.2 divided by 3 into e to the power minus t upon 20 by 3 into 10 to the power minus 6. अरे नहीं 1 2 3 4 ठीक है guys हो जाएगा ये question now. Will it be done? See the current. So you unwantedly basically I solved the whole question. I wanted you to apply this dimag, not me. I don't know, you don't know, you need to learn. So anyways, now please remember this type. Okay, next time if there is one resistor or many capacitors or one capacitor many resistors, then you'll do this. If it is like many resistors and many capacitors, then that question is out of scope of for your normal 12th level or JE level in exam. JE advanced I'm talking. NEET so they don't even have RC circuits. Okay. For NEET RC circuits is not there. Are you getting my point, everyone? Is it clear?
Yes, sir. So,
चलिए ठीक है. So we'll continue again in the next class. What is the time, by the way?